Alright, let's apply the chain rule in Leibniz's notation to determine dy over dx at the indicated value of x. And here's your equation: y is equal to u squared plus 3u, u is equal to square root of x minus 1, and x is equal to 5. So technically what we're trying to do here, find dy over dx when x is equal to 5. Right, we can see that we have to utilize the chain rule, right, because y is a function of u and u is a function of x, right? If you actually plugged in this equation into y, I'm just going to do this for an experimental purpose. So you have u is equal to square root of x minus 1, y is equal to u squared, so square root of x minus 1 for u. I'm going to substitute that in. I'm going to just write y in terms of x. This is another alternative way you can do this, right? But I'd rather you guys use chain rule. The reason I'm doing it this way is because I want to show you guys the domain and range, because it is going to be really useful to us later on when we find a derivative. So in this case, your equation here would be x minus 1 plus 3 square root of x minus 1. Okay, and you can see that the domain here, x belongs to all real numbers, but x has to be greater or equal to 1, right? Because we know that this portion here, the radicand, it can't be negative, right? So the lowest value you can have is x is equal to 1. So if the lowest value you can have is x is equal to 1, right, then the range here, if x is equal to 1, 1 minus 1 is 0, and 1 minus 1 here is 0, so the y value would actually be 0. So y will always be greater or equal to 0. So keep this in mind. And I'm going to show you guys how to do the chain rule here for this question. We want to find dy over dx. Well, if you actually find dy du and you multiply it, right, and this dy over du is the derivative of y with respect to u, which is this function. You multiply this with the derivative of u with respect to dx, or with respect to x, you can actually see that you can cancel out and you get dy over dx. Okay, so let's find each of these derivatives first. Okay, so let's find the derivative of y with respect to u. So this is basically the derivative of u squared with respect to u plus the derivative of 3u with respect to u, and this is 2u plus 3. So this is the derivative of dy with respect to du. Next thing you want to do here is let's look at u as a function of x. U as a function of x here is equal to, and you can write this as x minus 1 to the power 1/2. I'm just going to write it as a power. So du with respect to dx is equal to 1/2 x minus 1 to the power negative 1/2 times the derivative of the inside, which is the chain rule, but we can understand that this is 1. Okay, so now we have the derivative here. I'm going to change this to just positive exponents, so you can write this as 1 over 2 square root of x minus 1, right, because the negative 1/2 is the reciprocal. And if I combine these together, right, if I combine this guy and this guy together, dy over dx is dy over du times du over dx, right? So you get dy over du, 2u plus 3 times 1 over 2 square root x minus 1. Okay, and in this case what you want to do here is you want to substitute u here for square root of x minus 1. So you can write this as dy over dx is equal to 2 square root x minus 1 plus 3 over 2 square root x minus 1. Okay, now we can note here that the domain and the range here contain restrictions. Okay, and specifically we wanted to find the value of dy over dx when x is equal to, and I think I should put the line here actually, but x is equal to 5. So if I plug that in for x equal to 5, you get 2 times 5 minus 1 plus 3 and 2 times 5 minus 1, right? And we know that square roots are positive, negative, but because y has to be greater or equal to 0, we can only have positive values of the square root function. So we can actually have 2 times square root 5 minus 1, which is basically 2 times 4 plus 3. So I'm just going to look at the positive values. 2 times square root of 4, not 4, but square root of 4. And in this case, you get 2 times 2 plus 3. So only look at the positive values of square roots. And you get 2 times 2, which is 7 over 4. So that is your slope, right? So therefore, dy over dx when x is equal to 5 is equal to 7 over 4. So because of the restriction on the range and the restriction on the domain, y has to be greater or equal to 0 and x has to be greater or equal to 1. So because of that, you can only have the positive value of the square roots here. Okay, so that's our answer.